Alright class, so today you're going to do a virtual lab. You're watching the video right now, and then when you go back to the lab sheet, you click on the other link that takes you to an Excel spreadsheet. On the Excel spreadsheet, please be careful at the very bottom. I'll show you this in just a sec. There's a first hour tab, and or not a first hour, I don't have a first hour, but a second hour tab, a third hour tab, a fifth hour, and a seventh hour tab. And then you are assigned lab partners. There's, I don't know, several of you working in a single group. But make sure you use your data.
So when you click the link on the PDF of the lab that says like the data portion, it should send you a link to the spreadsheet. So it depends on what hour you're in, but obviously find your hour at the very bottom. Just click on that tab and then find your name, and that's the data you will use to do the calculations.
So the lab is basically this. We're going to start with 10. And I'm going to react the 10 with nitric acid. I think you can see that on the screen. Yeah. Plus HNO3. And we're going to get three different things. All right? First off, we're going to get water. Second off, we're going to get some kind of nitrogen oxide. So it could be nitrogen dioxide, nitrogen trioxide, dinitrogen trioxide, but some kind of nitrogen oxide. So I don't know what this X and Y are, okay? But some kind of nitrous oxide. And the last thing we're going to get is a tin oxide. All right? So I'll call these M and N since we already used X and Y. So with that information, we're basically getting a liquid, or producing a liquid, and you'll learn a little bit about these symbols our first unit, second semester. We're going to produce a gas, and we're going to produce a solid. All right? So when it's in the fume hood, you're going to see what this looks like. I'm making nitrous oxide, which is a major component of smog. So if you've ever been to a big city, LA, Houston, anything like that, there's kind of like an orangish haze that's always above the city. That's mostly nitrous oxides from exhaust from both cars and like manufacturing plants. Water, obviously, you know what water is. But we're going to make some kind of tin oxide. So because tin is a transition metal, you don't know what its charge is. So kind of when we went back to naming, when we learned naming earlier, tin is either a +2 or a +4. Okay? You just don't know what tin you had to start with. I do, you don't. So what we're going to do is we're going to determine the empirical formula of tin oxide by knowing the mass of tin to begin with. And then we're going to know the mass of my tin oxide. So if I know this mass and I know this mass, if I subtract the mass of, so if I basically take tin oxide, which should weigh more, and I subtract out the mass of tin that I started with, that result should be the mass of oxygen that I added to my tin oxide. So then if I have mass of tin and mass of oxygen, I can change this to moles, divide by the smallest, and we get an empirical formula. Okay, so that's where the lab is going. We'll start with the procedure right now. All right, so procedure-wise, this is called an evaporating dish. For obvious reasons, we're going to evaporate stuff out of it. So we're making three things: a tin oxide, water, and then the gas. So essentially, we're going to have that metal with a bunch of water and kind of just some impurities as well, which we're going to boil out. So I'm going to set it on here. It weighs about 49 grams. And I just want to add enough to have about 2 more grams. So whenever you look at your lab data, you're going to have a number, which is the mass to begin with. And then I'm going to add it so it's close to 51. So I want about 2 grams of tin. A little bit more. There we go. That's pretty close to 51. So 1.9, whatever. This is granulated tin. So it's tin that's just been like run through a machine that just ground it up into really, really fine pieces of tin. All right? So the next thing I'm going to do is I'm going to take this over. Let me see what I can do about changing this angle. So I'm going to bring this over here in the fume hood. This is pretty much the only time we use this all year. And because of the gases that we make, I kind of said it's kind of major components of smog. So I'm going to pour nitric acid onto the tin metal. And you can see it bubbling immediately. Alright, so we'll come back kind of in the middle of the process, but you see these bubbles forming? And inside the bubble there's like that orangish gas. That is basically little smog bubbles. As that big bubble forms, smaller gas molecules evaporate into that big bubble, which gives us the brown color. And it is still reacting pretty good, so I'm going to pause it again, and we'll come back pretty much when it's done and move on to the next step. Alright, so at this point, we are good to go. You can kind of see, kind of what it looks like. It's almost like a white paste. It's going to be hot on bottom, so what you do is we're going to bring this over and set it on the hot plate. And notice the temperature right now is 135. What's going to happen over the course of the next 20 minutes is it's going to stay on here, and after 5 minutes I'm going to turn it up to 270, and after 5 minutes 405, and after 5 minutes we'll turn it all the way up to 540. So it's going to stay on here kind of just on ever increasing heat for about 20 minutes, because right now we're trying to get all the water out. So it's called an evaporating dish because we want to get all the water out. You can see there's still kind of some bubbles, some small bubbles forming, which is the nitrogen dioxide. So again, as heat is added, the rest of that gas is going to come out as well. And typically on a typical day, the room smells really, really bad as all this is coming out and kind of just filling the room. So anyways, I'm going to pause it probably really for the next 20 minutes, and then you'll see the next step after 20 minutes. Alright, so this is after 20 minutes of heating, and you can kind of see that it's like white crust on top and like red underneath. It's kind of like the, I don't know, the planet of Crate and the, I don't know, episode 8 of Star Wars, right, where you have those like speeders going across and it's like throwing up red dirt. So I'm just going to kind of crunch this up a little bit. It's going to turn more red, and if you could see it, maybe right around here, you can see like more gas coming out, more of that orangish gas. And I'm just going to break up those kind of big piles of stuff, and those big piles just had a little bit of water in there, probably just gas trapped within the solid. So now what's going to happen is, with an UV glove, because this thing is crazy hot, I'm going to pick it up, and it's just going to get transferred over here, right up there. And I'm going to take this off, and reposition stuff. Alright, so I'm now going to go ahead and find my matches, turn the gas on, open this up, and I'm going to light a Bunsen burner. And heat, like flame heat, is hotter than electrical heat in most instances. So I'm going to change this to blue flame, and hopefully have this about, so it's hitting the bottom, so I'm going to lower this a little bit before it gets hot. There we go. So now we're just going to heat it again for about 5 minutes under really strong heat, okay? And hopefully that's going to drive out the rest of my water and my gas. And what will happen is we'll take it off, weigh it, come back, heat it again, take it off, and weigh it. So typically if there's any time we're ever getting water out of a substance, we'll heat it and weigh it twice. And if our weights are close to each other, it means we got all the water out the first time. Because water is impossible to see, and it's such small molecules. You might think you have it out, and you weigh it, and you bring it back and heat it again and weigh it, and if its weight drops a lot, it means you didn't get the water out, all the water out the first time. So then you are going to end up heating it 3 times and weighing it 3 times. But weighing and heating twice ensures to you that you got all the water out. I'm just going to break up some of these bigger chunks again. And we'll let this go about 5 minutes, and we'll do our first weighing, and then we'll come back, heat it, and weigh it a second time. Alright, so we'll pause it again. Alrighty, so we are back after about 5 minutes of heating. What I'm going to do is I'm going to turn the gas off, alright, because I don't want to catch the glove on fire. But now you can see kind of what it looks like. It was kind of like that white pasty when it came out of the fume hood, and it had quite that white cover on it when we took it off the hot plate, and now it's kind of this orangish, reddish, I don't know, looks like maybe what Mars would look like or something, I don't know. But I'm going to pick this up, and I'm just going to put it right on the counter, and from here, we're going to let it sit for about 5 minutes to cool off. because it needs to be cool before we weigh it, all right? So essentially, let it cool. All right, so we have been waiting while this cooled off. Now it's cool enough for me to actually pick up with my fingers. So I'm gonna zero this out real quick, and we're gonna set this on here. And remember it weighed around 51, I don't know what it was, 5104, 5108, something like that. But notice my mass is bigger now, because no longer do I just have 10, but throughout the reaction I added oxygen to that 10. So my mass went up. What we would typically do in lab is I would reheat this, let it cool, reheat it again. Because we're doing this on video, I'm not going to worry about doing that second for you. But on the Excel spreadsheet, it'll just have after the last heating, okay? So anyways, that is how the lab, that's the procedure for the lab, that's what we did for the lab to get the numbers in the data table, and that is it. So enjoy doing the lab, like the write-up of the lab, which is usually the not enjoyable part. But anyways, if you have questions, let me know, but that is the Empirical Formula Lab.